Hey guys, I'm back. I was able to pull up the latest MLSO run, Mauna Loa Solar Observatory, the K coronagraph in Hawaii. And as you can see, we still got a lot of stuff flying around here. And they would appear to be getting bigger, in my humble opinion. Now this is the unsanitized version. If you go late in the day, or whenever they post their video for that day, if they post one, you'll find the unsanitized version. If you go in tomorrow, this thing will be sanitized. A lot of this stuff streaking around, it's not going to be there. And then these planets that are with concentric circles show up better once they peel off a few layers. That's what I think they're doing. They peel off some of the layers. So, I mean, these are obviously not fireballs streaking around, but they're up somewhere pretty close, but not that close. Not close enough to be in our atmosphere. Anyway, that's that. Here's the same deal. Same run, the 24th. Different perspective. But, I mean, check this out. Okay, if you watched the video this morning, remember I put up my hypothesis about the big planet that was blocking the solar wind from ACE, and it wasn't blocking on Discover satellite, and then they were both up there at Lagrange point 1. So here's Lagrange point 1. ACE was launched up there in August of 1995 to record everything coming from the sun, to give early warning as much as 15 to 60 minutes before it got into our geosynchronous orbit area where the satellites mostly go round and round. And then Discover was put up in July of 2016. So it's a newer satellite, but it records the same data of solar wind from the sun. So anyway, if you've been watching my videos, ACE has been blocked for like periods of 4 to 5 hours initially back about 6 months ago, and then as much as 8 or 9 hours just up until last week, when on the 16th and 17th all of a sudden there was no blockage, and it used to be a 9-hour block. So I was theorizing that there was some kind of a big planet up there that was blocking the solar wind data from reaching ACE, because it was showing up on Discover that whole time. And Discover's up there roughly the same place at the L1 Lagrange point. And then also, if you've been watching my videos for some time, you'll notice that the solar wind speed does not correspond to what's been hitting in our magnetopause. We get a sporadic fluxion. We get sporadic hits where all of a sudden there'd be a big hit on the magnetosphere and magnetopause, and would knock the bow shock way back, like it's still doing here. You can see the bow, there it is, wow, boom. Okay, now the solar wind speed recorded on ACE, which is up there at the L1 Lagrange point, and Discover, either one, does not correspond to these hits that we're taking on our magnetopause. So I theorized that whatever was up there has a magnetosphere just like the Earth does, and every once in a while we're going to get a link where our magnetosphere is going to link up like an interplanetary magnetic field connection between the Earth and whatever this planet is. And whenever that link occurs, it slings the solar wind at our planet, and that's the reason why we're getting these fluctuations. So I theorized that when the blocking planet passes ACE, which it did on the 16th and 16th this month, watch for the gaps to begin showing up on Discover. Well, it didn't happen because they took the Discover satellite offline. So here's what I found out. I went in today, to check ACE, like I usually do. And there's the last 3 days on ACE. And also these sporadic, see these dots here and there? Where, you know, all of a, there's just not a straight line like there should be, like there is on Discover. See, there's more of a straight line. You get some fluctuations there, and of course there, but that's a magnetic reading. It's not a density or solar wind reading. So you got these fluctuations on ACE, and I have theorized that the magnetosphere from this planet is causing a disturbance. That's why they're getting funky readings there. So anyway, okay, I pulled up Discover today, you know, thinking it was going to be still offline, right? And it wasn't. All of a sudden, now they have Discover back online, and so I even pulled up the last 7 days, and there it is. The last 7 days on Discover. And as you can see, there's no gaps. So here's the point. And then I scroll down to look, and then I see this. Okay, ground tracking status for the Discover satellite is available here. So I click on that, and this is what comes up. So they have a schedule where there's ground tracking units in different parts of the globe, apparently, that pull the data from the satellite. And as you can see, I pulled up the last 7 days, and this is about when it went offline. They quit showing it to us. And that's when I started thinking that there was something going on with the big planet that disrupted ACE data collection is now disrupting Discover in some form or fashion. So, okay, well, let's see how long Discover stays down. So, I don't know if this is a coincidence or what, but I just posted that this morning, and all of a sudden they got Discover back up online, which looks like a clean data stream. Maybe they did some filling in on their own, I don't know. But it looks like more than half of the ground station, well, half of the ground stations aren't reporting. It was more than half in these couple of days. So here's what I'm thinking. Whatever that big planet was, it was blocking on ACE. Since they're both up there at the L1 Lagrange point, when it finally passed ACE, okay, it didn't go in front of Discover, but rather it wandered behind Discover. So it was blocking the data collection from Earth to Discover. So that's why they took it offline. Oh well, anyway, that's my theory. I'm sticking to it. So here's the latest 300 frame run on ISWA. I scrolled through here real quick. There's no missing frames. I got these three synced up together, and these two are synced together. This is the lowest low energy electron recorded electrons. They're the ones that move the slowest, and it's recorded at the lowest level, 10 keV. And these are the highest high energy electrons, the ones that zip around the quickest, and they're recorded at 4,000 keV or 4 MeV. You can see we still got a ton of solar wind pressure from the backside coming from Nemesis, which Nemesis emits mostly electrons and our sun mostly protons. So hence the binary twin, the equal opposite Newtonian physics law would be in effect there. And clearly you can see we're getting a whole bunch of electron bleed around the planet. Didn't show up as much on the MLSO as it did a couple of days ago when I posted it when it was all blacked out, remember? Well, it was all blacked out on this one. But, I mean, and let you see that again. That was it's pretty wild, some of these things flying through here. I mean, they're big. These are like 15-second increments, and then shots every 4 minutes. So I don't know, maybe you're getting to see 4-minute drag through the shot. It's a video, but they got it broken up into 4-minute intervals. I'm not exactly sure, but I don't think they're zipping through. My point is, as fast as they would appear to be. Be nice to see just a regular, normal speed view of what the heck is going on up there, would it not? So anyway, we're back to here, and this morning I showed you that was pretty crazy stuff with the magnetosphere being compressed from out here at 11 all the way down to 7.5 with that one shot. And then I showed you on ACE that there was no corresponding solar wind. So that's the deal, guys. And I pulled up here the University of Michigan latest geospace run. Get like a 4-hour, 3+ hour, 4-hour run. And this is the pressure. So you're seeing pressure equal, it's almost equilibrium status again, where hardly any pressure variable or difference between what's coming from the sun and what's coming from Nemesis. All you see it there, when there is some pressure, it lights up. Looks like there was a couple hits there. As let's see, when it rolls over, it's going to go up to around 20 and then roll back to 17. 21. It should be rolling back. 22. There it is, 18. So why isn't it playing? There it's playing. I thought I saw a little blip in here. Maybe not. There's the density. Well, you don't really get to see too much with that. So we'll go back to here. Oh yeah, geez, I got so excited I almost forgot to pull up this Himari-8 latest run to show you the planet's still there. See, everything's pixelated out. Same time, same station, Batman. 1340, you can see some light showing down here below Australia. We'll step it through. Looks like the light's a little bluer to me, whatever that means. And you can see it, they got this whole thing pixelated out. So this thing's showing some, probably putting off quite a bit of light. I'm really surprised nobody's posted any pics on this, or if they have, I haven't seen them. I wish somebody did catch something like this. Shot from Australia or South America at 11 p.m. or somewhere around there. This is 11 p.m. Australia time, Melbourne time, and it goes by on the other side of the globe on the goes east. 16 east at around 11 p.m. Somebody should be able to catch some shots of this. So to reiterate, here's the last 7 days on ACE, and the gaps quit showing up on the 16th and 17th. They didn't show up at all, and they had been showing up for like 6 months, 8-9 hour gap. Then all of a sudden on the 18th we had like a 2, 4, 5 hour gap, and then it went back up to a 2, 4, 6, 8 hour gap on the 19th. Then on the 20th, it went back down to a 6 hour gap. 21st, about a 5 hour gap. Then we got these sporadic little 4 and 5 hour gap. And then all of a sudden, no gaps. That's when it finally passed ACE. And that's when Discover went offline, right on the 25th. Oh, I'm out. Peace and out. Peace.